Welcome guys. Before us we have a question in Math Paper 2 for the year 2023, and we are dealing with a paper that was written by the internal candidates. Now I just want to promise you something. If you just follow the rules of mathematics and if you practice more with mathematics, maths should not be an issue, and I can promise you that as long as you do what is required to be done, then you are going to pass this mathematics. Now let's look at this question. We have been given a question under matrices. Now we are trying to find the value of x given the determinant of this matrix. So how do you find the value of a missing number by given a determinant? So the concept that we are going to use here can be applied to any question as long as it is under the same topic. So we have question 2a, given that matrix K is equal to this matrix, find the value of x for which the determinant of K is 2. So I'm going to write my original matrix K. So this is our matrix K. 8 and x. So this is our major diagonal. So it's very important to identify this. Then 1 and 9x, this is our minor diagonal. Now what's the formula to find the determinant? So the determinant is found by the difference between the elements. So we need to find the product of the elements of the major diagonal subtracted by the product of the elements of the major diagonal. So how do you do that? So it's we need to multiply 8 by x. So you say 8 times x, you close the brackets, minus, always you subtract, open brackets. So we are going to multiply 1 is from the minor diagonal by 9x from the minor diagonal. So it's 1 times 9x. That is your first step. Now if you look at this question, we are given the determinant. So determinant of K is 2. So where there is determinant, we are going to put 2. So we just have to do some calculations. We'll say 8 times x is 8x minus 1 times 9x is still 9x. Then here we can just do some math. Now we are not going to shift any number or anything here, since we already have the like terms on the right side. So just say 9x minus 8x is x, but we are going to get the sign from the bigger number, so this will be our negative x. So we can't leave a variable with a negative, so we just have to divide by negative and also here by negative, so that if we cancel, we have x is equal to negative 2. So that's our final answer. Now let us write our original matrix, but this time we are going to plug in the value of x. So this is 8, so x is negative 2. So here we are going to have negative 2. Excuse me. Then we have this expression of 9x. So if we substitute where there is x with negative 2, we get negative 18. So this is the number on this position. On this one we have 1. And if you want to try, if your answer is correct, you can try to find the determinant using the actual matrix K. So if you look at this question, it's 8 times negative 2. So 8 times negative 2 will give us negative 16. Then 1 times negative 18 will give us negative 18 times the negative will give us positive 18. So if you subtract, we are able to get the same determinant. Now for Roman number 2, we want the inverse of matrix K. So what is the formula for the inverse? So the inverse can be found by, so K raised to the power 1 is equal to 1 divided by the determinant. So for you to find the inverse, you need to have the determinant. But in our case, determinant is given, and we said the determinant is equal to 2 multiplied by adjoint. Now what is this adjoint matrix? So 1 over the determinant is given is 2 times the adjoint matrix. So the adjoint matrix, for the major diagonal, you just have to swap the numbers. So they need to interchange the positions. This means that this negative 2 must interchange the position with the 8. So negative 2 will go where 8 was, and 8 where negative 2 was. So that is what happens to the major diagonal during the adjoint of a matrix. Now, what of the minor diagonal? So with the minor diagonal, you don't have to change the position. For this one, you just have to change the signs. So this is negative 18, but in the adjoint, you put positive 18. Then this is positive 1, here you put negative 1. So we have 18 and negative 1. So this is our final answer. If you want, you can expand by multiplying 1 over 2 with everything in this matrix. We move on to question 2. So under question 2, we are given a set, and the first question is about drawing a Venn diagram. So let's read through the question. A survey carried out in a certain district showed that out of 215 teachers, 1/7 taught mathematics, 100 taught additional mathematics, 41 taught computer studies, 65 taught mathematics and additional mathematics, 30 taught additional mathematics and computer studies, 26 taught computer studies and mathematics, and 21 taught all the 3 subjects. So this point is very important, where you are given a number indicating that did everything. So what is our first step when you are writing a Venn diagram? So you need to draw a rectangle. Now in this rectangle, we are going to write 3 sets. Why are we going to write 3 sets? Because we are dealing with the 3 subjects. So the first one is mathematics, the second one additional mathematics, the third one is computer studies. Now, when writing these 3 circles, we need to make sure that they intersect at one point. Why? Because we have a number showing that there were some teachers that taught all the 3. So we need to have the intersection of mathematics, so just say AM, additional mathematics, then computer studies, we just say CS. So we need the intersection of the 3 because we have the number that did all the 3. And the number that did all the 3 is the first number that you're supposed to indicate here. So you look at this one, 21 taught all the 3 subjects. So 21, they taught mathematics, the same teachers taught ADMA, the same taught computer studies. So 21 must be written here. That is your first step. Now, after you are done putting those that did the 3, you need to look at those that did 2 subjects. So the first one is this number 65, taught mathematics and additional maths. Maths and additional. So if I were to draw maths and addimal, we can see that we have 21. So 21 is part of the 3, is 21 is also part of the 2. So this shaded region must be equal to 65. Now, from that 65, we already have 21. So to put the number here, you need to subtract 21 from 65. So that's the concept that you're supposed to do. So say 65 minus 21. So I'm getting 44 is my answer here. Then we move on to 30, taught addition mathematics and computer studies. So addition mathematics and computer studies is this region. So we are told there were 30. Now from 30, we need to subtract 21. So 30 minus 21, we get 9. So 9 is what we are going to write here. We move on to the second point. So 26 taught computer studies and mathematics. So from that 26, we are going to subtract 21, which is we get 5 here. Right, so after we are done, we need to now look at the first statement for each subject. So 170 taught mathematics. So from the set that is indicating mathematics, we have 44 is part of mathematics, 21 is part of mathematics, 5 is part of mathematics. So I need to add the 3 numbers that are part of mathematics, then subtracted that sum from the total, which is 170. So we'll say 44 plus 21 plus 5 is equal to 70. Or to simplify, I'm saying it simply means this. So we are saying as long as this is mathematics is equal to 170. So let's say we put x here. So to solve x, we can say x plus 44 plus 21 plus 5 is equal to 170. Then if we add the 3 numbers, we get 70 is equal to 170. So if we take 70 to the right side, will give us negative 70, giving us 100, which means that here there is the value of 100. So this is the concept. I thought of maybe if I can make a visual representation, I can simplify things. So that's what you are supposed to do. So we are going to do the same with additional mathematics. So let's look at the numbers that we have in ADMA. So in there, 44 is part of addition mathematics. Then 21 is part of mathematics, 9 is part of mathematics, and this must be equated to 100. We are told 100 did mathematics. So we are equating this to 100. Then let's put x here, because this must equal to 100. So we'll say x plus 21 plus 9 plus 44 is equal to 100. So 21 plus 9 is 30. 30 plus 44 will give us 74 is equal to 100. So if we shift this number to the right side, is equal to 100 minus 74, giving us 26. So this is the number. So for the numbers that we are finding, like 100, 26, these are the numbers that represent the teachers that taught only one subject. So that's a concept. So for these teachers, if it's maths only. If it's ADMA, it's ADMA only. If it's computer studies, they did that computer studies only. So that's a concept here. Now we move on to question for computer studies. So computer studies CS has numbers 21, 9, 5. This must be equal to, what is the total? So 41 taught computer studies. So we're going to equate to 41. So we put x again. So let's solve for x. So x plus 21 plus 9 plus 5 is equal to 41. So x plus 21 plus 9 is 30 plus 5, 35 is equal to 41. Then if we shift 35 to the right side, we get negative 35, giving us the final answer here is 6. So 6 taught computer studies only. So we are done now filling in the Venn diagram. Now the remaining part here is we need to find the sum of all the numbers that we've written under the Venn diagram, because we need to check if the sum will correspond with the total number that we are given in the question. So we have 100 plus 44 plus 21 plus 5 plus 9 plus 26 plus 6. So I'm getting to 11. Now let's look at the total. So look at the total. The total is 215. So 211 taught something, but the total is 215. So if we subtract 211 from 215, we are going to have 4. So 4 were the teachers that did not do anything. We move on to question number 2. How many teachers taught? A, none of the subjects carried out in the survey. So the answer for A is 4. Then B, additional mathematics or computer studies, but not mathematics. So if you look at or is associated with addition. So we need those that did mathematics and computer studies, but or we can say or can be associated with the universal, the union I mean. So what is the union of maths? So it's like addition mathematics, union computer studies, then intersection maths complement. So that's the concept here. So addition, under addition mathematics, we have numbers like so we have numbers like 40, 44, 26, 29 and 21 and 9. Then computer studies we have 5. So the key point is we don't have to include anything that is in math. So the remaining part is now what we are looking for. So we have 26 plus 9 plus 6. So 26 plus 9 will give us 35 plus this one is 41. Then for question C, we just want 2 subjects only. So C is equal to 2 subjects only. Let me first get rid of this. Right, so 2 subjects only is 5, because 5 did maths and computer studies. So 5 plus C, the second one is 9, because 9 did ADMA and computer studies, plus C, 44 did maths and ADMA. So 44. So if we add 44 plus 9 plus 5, I'm getting 58 as my final answer. So that's it for this video. So if you find this video interesting, please give it a like, subscribe, share with friends, and you also please I'm asking you to comment, because it's very important for me to hear from you. And if it's possible, write in the comment section where you are watching me from. So that's it for this video. Thanks for watching.